That is integration by part, that is uv minus integral of v gu. The next question we are going to ask now is what is our u and what is our v? Okay, we take u as what? U is equals to cos x is equals to x, sorry. We take our u is equals to x, so that gu will be equals to 1. And you're already eliminating a constant, a variable to have a constant. Because if you take our u to be cos x and differentiating, we are going to be having a circular formula that is a periodic, because cos is periodic and will never come back to 1 or anything. You are just going to be turning to cos to, from cos to sine, just changing a negative. We are going to take our gv is equals to what? Cos x. Therefore, our v, we integrate cos x. From our circle, we have sine, cos, minus sine, minus cos. We differentiate like this and we integrate like this. What are we having here? Cos x. And you ask to integrate. Okay, we integrate, you have what? Minus sine x. Minus sine x. Oh, oops, what am I even saying? We have is cos x, not minus cos x. We have cos x and we integrate to have sine x. Sorry. We integrate to have sine x. That's amazing. That is already what we have, because the formula of integration by part is that the integral is given as u dv with a gx, because u and dv are in terms of x. Okay, there is somehow how it look like, and you just have to substitute in this formula. Okay, we take our u as x and our v as this. You just have to substitute everything back. Uv, that is uv, x sine x, x sine x minus the integral of what? V du, that is sine x. Oh god, you are just done. We are done. That's x sine x minus, if you integrate sine x, you are going to be having minus cos x, that is plus cos x plus a constant k. And that's amazing. What if you had the integral as integral of x cos x with from 0 to 1? All you have to do is to remove this k and just introduce a limit 0 to 1. I'll just drop it so that you guys solve it and substitute and give me the final answer. Substitution, we have 1 sine 1 plus cos 1 minus that of 0 and cos 0. I have something funny as an answer. We come to the end of this amazing video. Goodbye.